Good afternoon. This is the Board of County Commissioners Board Work Session. It is Wednesday, June 7th, 2023. It is 1:35 p.m. This session is set to go until 2 p.m. This is a hybrid meeting. We're at 3000 Pacific Avenue Southeast, room 110. Is it being live streamed?
Yeah.
Or are we just recording it?
It's live stream.
Okay, so for public virtual attendance, you may follow along on the Thurston County YouTube channel. I apologize. We've been having some technical issues today with the live streaming. I'm Carolina Mejia. I'm the chair of the board. Vice Chair Ty Menser joining us via Zoom, and Commissioner Gary Edwards will be joining us in the boardroom shortly. Also, and we're here to discuss the Tri-Lakes Groundwater Monitoring and Modeling Project update. And we have staff from CPED as well as environmental health. We've got a little bit of everything. And so who's gonna?
Right to Art.
Right to Art?
I'll introduce things quickly and then I'll turn things over to the stars of the show, Kevin and Stuart. So I'm Art Starry. I'm the Environmental Health Division Director for Thurston County Public Health. And this project, actually, it's an opportunity. We were actually able to work, I say we, meaning CPED and Public Health, were able to work with the Department of Health on this project. And I think it's really important because it helps us better understand the, I guess, hydrogeology and the groundwater system that feeds wells and water systems that serve a large portion of Thurston County. So Kevin will put a map up here in a bit, but it's what we're talking about is the Tri-Lakes area, which is the Hicks, Long, and Pattison Lakes. So it's kind of going, you started up in the Hawks Prairie area and went south, down through the lakes and down into the agricultural areas south of Yelm Highway. That's the area it encompasses. And it has quite a history as far as having different efforts on it. There's been instances where there have been land use activities that have contaminated groundwater. If you go back long ago, even in the 80s, agricultural practices resulted in pesticide contamination of wells in the area that resulted in having to abandon a bunch of water supplies and bring public water supply in. There's been other efforts to try to identify pollution sources and do lake management activities. There's about 550 something wells in the area, including some big production wells for the city of Lacey and Olympia. The area encompasses part of the wellhead recharge area for the city of Olympia's McAllister well field. There's over 10,000 septic systems in the area. It's an area that has grown rapidly. There have been different efforts and activities over the years to try to make sure that the water resources are being managed properly. The McAllister Springs geologically sensitive area encompasses part of it. So it's a big thing. And so what this effort did is a contract that we were offered by the Department of Health that was actually Jane Mountjoy Venning started negotiating it a couple of years ago, and it was actually approved by you as the County Board of Commissioners about a little bit over a year ago. And since that time, staff have been working on the project to both do groundwater modeling, monitoring, and use that information to update the groundwater model that Kevin manages so that we can use that to better understand the groundwater resource, evaluate potential impacts of pollution impacts, and help protect it in the future, because that's really what this whole thing's about. If something really bad happened out there and for some reason some of those wells were not able to be used anymore, it would have a huge impact on the community. I don't know the exact number of users in Thurston County, but I bet there's probably 50% of the people in Thurston County get water from that area. I mean, it's a big deal. So it's a big resource. So this effort allowed, again, our staff to go out and grab samples. There are a bunch of wells that were selected, and we'll talk about that, and use that information to update the groundwater model and better understand the quality of the water, the impacts, maybe some of the risks of some of the water supplies there. And there was also some work we were able to do in conjunction with the University of Washington, Tacoma, to identify or evaluate some other potential pollution sources that might be influencing wells, so we could better understand what the sources of pollution are basically nitrogen and other things where it's coming from. And Kevin will talk about that. So I'll just, without any further ado, I will turn things over to Kevin and Stuart, because I know we don't have a ton of time, and it's I think a neat project.
Thank you very much. I guess, Ramiro, you're driving the show.
I'll give you the mouse here in a second. I just want to start the
within the slideshow.
I know how.
So the genesis of the show, of the project, was that we have these resources now. We've come a long way in terms of knowing where septic systems are and in having the technical analysis tools to be able to forecast where their part of the contribution to contaminants might go. And that's part of the modeling that's been developed over the last 7 years. So the focus of the study was, first of all, one key question: what fraction of the total material we see in groundwater is caused by septics versus other sources? That's sort of number one. There's been a long-running debate about the fraction of contaminants that might be caused, might be caused by septic systems. We're going to try to address part of that here. So, all right, how do I advance? There we go. We knew going in from the yellow, orange, and red dots on the map that we had some contamination. This is over 30,000 samples represented here, collected from the 1980s through the present. Anything, and the color coding you're about to see here is going to carry throughout the show. Yellow means it's at or above the county's early warning level, EWL, of 2 milligrams per liter for nitrate. Orange or above is above 4 milligrams per liter, and red or above is greater than the federal maximum contaminant level of 10 milligrams per liter. So we knew we had a problem, but you know, you can't look at everything. So we focused on, we focused first on septics. And septics were something we had good records on, better records than almost anything else. We took the septics data built from the 1990s through the present and updated it with occupancy data to get the same color coding you see on this slide as you saw on the prior slide. The difference is this is the originating source concentration from septics. So again, the yellow, orange, red coding applies, but this says where is the loading, the sort of originating concentration within the bracketed ranges we just described. We chose the Tri-Lakes area because of its high density legacy septic questions, legacy being important here. There were a lot of septics installed before modern regulations, and that's a big deal. So, what I meant to say was the red blob you just saw was the area of the study. Key project question: lots of septic systems, but other sources are known to contribute. Lawn, yard care products, animal waste, agriculture, stormwater. What piece of the problem might be caused by other than septic issues? So we obviously have a very wide range of septic install dates. So when did the contaminant sources originate? We couldn't tell precisely. To simplify the modeling, we took the peak of the distribution dates for the majority of the majority of construction dates for the homes in the area, presuming that if they had a septic and we knew when they were built, they were probably on septic about the time they were constructed. That gives us a peak around 1980. And that was the start date for the modeling and the presumed beginning of the contaminant plume. So this is an animation you're about to see. This was produced by the county's groundwater modeling efforts. It's a county product that can be updated and used in other places. Let's see if it plays. You see the blue blobs beginning to form. The model layer you're looking at is the sea level aquifer. It's an extremely important aquifer in Thurston County. And the color coding, again, is the same as we saw in other slides prior. So that if it's yellow, it's above our early warning level, orange is above our contaminant action level, and red is above federal maximum contaminant level. Now, this is not just at surface. This is 100, 150, 200 feet down, depending on the layer. And it is showing evidence of septic-based wastewater loading at that depth and deeper.
So how long, for the model run, how many years did that represent?
Oh, I'm sorry. It's a little bit hard to tell. Let me drag this box down here and play it again. In the upper right, you see a little time counter, and it's measured in days. Apologize for that. I'll play it one more time. So that's 10 years. 20 years, 30 years, and finally, 40 years maximum contaminant simulation time.
So that was running from, say, 1980 to 2020?
That's right.
Okay.
That's right. That's right. So notice the problem, I'll call it latency. It takes a long time for the results to actually hit. So we may drill a well and it may be fine. 20 years from now, we may have a problem and we might have known what that problem was. So one of the things the modeling tells us is caution is important. And let me, how do I break out of this thing and skip to the next slide?
Yes, it should go to the next slide. It clicked for me. You don't move the finger up and then, now try it.
Yeah.
What's it doing?
Right click next.
I click
Up in the top?
next. Okay, so
This is scary that I knew something about PowerPoint. You guys didn't.
it took months of work, okay? We knew we had 500 and some wells out here. We mailed letters, postcards. The health crew was out day after day after day trying to find people. And it really, the best method was door knocking. So in the end, of the 554 wells we knew existed, we were able to sample 58, a little over 10%. We felt that was pretty good. We were able to sample Group A, big community systems, smaller community systems, Group B, domestic, and even a few monitoring wells.
Kevin, could you move the box back up?
Yeah.
Move Commissioner Mentzer's head now. Removing your box.
Okay, there we go. So, Stuart, do you want to describe the sort of outcome of the nitrate sampling?
Yeah, so we did, this table just describes the results for nitrate compared to our trigger levels and to the maximum contaminant levels of federal and state MCL and the type of well. So the only MCL or really big problem was a monitoring well, actually, which isn't a big deal because it was a monitoring well. It's not being used. It's just an old, I think it's an old county well, is it not? But as you can see, we had a number of wells, some domestic wells that failed the trigger level. We had 3 that, also struggled with fluid levels, et cetera. The point is that everyone that had an issue received a very detailed letter about what this actually means. What are the public health issues associated with nitrates? Over here on the western side of the state, it's not as big a deal as in eastern Washington, where we have more incidents of blue baby syndrome, which is something that nitrates causes because it impacts the ability of the red blood cells to absorb oxygen. So anyways, so the people that volunteered to let us sample, if there was an issue, we sent them a very detailed letter, like I said, explaining the public health impacts and resources they could tap into to address. Basically, if somebody's exceeding an MCL, we say you should be drinking bottled water. The problem is trying to treat this stuff is very expensive. And we have a lot of elderly people that helped us out in this area. They don't have the money to pay for a treatment system. And so we have one couple that is, the husband's very ill. And so we're saying you really should just be drinking bottled water. So that's what this talks about. But basically, so 28 of the wells exceeded the early warning level and above.
Again, so the early warning level, again, is 2 milligrams per liter. The federal standard is 10. These different things, again, are intended, like the name implies, early warning levels. When you see that, that means you should be looking at activities that might be influencing the water quality or the land use activities and other things adjacent to the well, so you can kind of help evaluate the significance of the problem, or if there is a bigger problem.
Okay, so when you compare the model snapshot shown here to the actual concentrations, we see a pretty good fit. I'm not going to go through those one by one because the next slide shows something that's really crucial. The modeling showed and the sampling confirmed that we have some wastewater related substances, using nitrate as an indicator, that have gone through the upper confining layers and are spread at low concentrations throughout the upper part of the aquifers in northern Thurston County. That's sort of one of the big takeaways is that we know we have wastewater.
What this is showing, it shows groundwater flowing from south to north, correct?
That's right.
Because that's, in that area, that's what happens. So down in those agricultural fields in the south, groundwater, the recharge area for these wells is down there. Groundwater flows subsurface and moves up north, and it's going to be discharged into Puget Sound somewhere.
That's right. Now, one of the key things I'd like you to see, these grayed out layers you see on this cross section, and this of course is a cross section through the earth. Those are confining layers. Our critical areas ordinance presumes they're not going to let things move downward. Turns out that's not true. There is wastewater stuff getting down through the confining layers that we wish were more effective than they are.
How deep down, Kevin?
The deepest wells we've got, 400 or 500 feet, show some contaminants. It declines with depth, but even the deepest wells have.
When you say some, does it come close to the 2% that it is a state thing versus the federal's 5% or something?
Yeah, actually, Art was mentioning it. The state steps in at 5 milligrams per liter. The feds step in at 10 milligrams.
What's the test on this one? When you say you get down that
Okay.
far?
This is for nitrogen concentrations.
Yeah, but is that also gauged that way when you say you have samples?
Yeah, it is. It's
So
the same color
high
code.
level, low level, when you get way down here, you can't hardly detect it, or
It's present at low concentrations. You can
which
see it,
means?
which means you don't have to shut the well down.
No, but I mean, still down to 1/10 of what the state does or the feds do.
Yeah, low. It's
Yeah,
low.
so like
but
the
it's present.
McAllister well field, they're generally below 2 milligrams per liter, so that's really, that's quite low.
Commissioner, hold on to that question for a second,
Oh,
because what
okay.
Stuart's about to say is going to address this, I think, in a more specific way. Okay, so remember the first question, what fraction of the total problem was caused by septics? Remember that, Gary, it's one of the things that we wanted to emphasize. Can we quantify what portion is septic and what's not? If we take the model results, the best fit happens when we multiply them times 140%. In other words, the modeling was too low to match actual concentrations. So what was the reason for that? Well, a couple of possibilities. Number one, septic wastewater could be more concentrated than we realized. Or number two, other sources could contribute. Both of those are important. This basin is the Woodland Creek Basin where we've had a long-term enforcement process, good compliance rates. I don't think septic wastewater is worse than we expected. I think personally, other sources are at play. Okay, so part two, we got UW Tacoma to step in, and if Stuart would be able to describe that, it really helped us understand this.
So you guys are familiar with the LOT project, the groundwater project, where they're testing for, dispersal of their treated effluent and stuff. And so this is the same process of sampling for chemicals of emerging contamination. This is a research laboratory, UW Tacoma, Center for Urban Waters. And so they have a process where what we're going to present to you is not actual concentrations of contaminants, but rather detections of chemicals based on their molecular weight. For us to actually determine whether that chemical is present, we actually have to do an analytical laboratory test to verify it. But
This is
the
kind of a screening method.
yeah, it's a screening method, but the confidence is really high because they've standardized over 1,000 chemicals by molecular weight, and their mass spectrometer will pick up those and verify that it's likely this is that particular chemical. So it looks for things like food additives, commercial chemicals, industrial chemicals, pesticides and herbicides, and pharmaceuticals. Next slide. So this is the initial output of their results after going through their procedure. And on the left is the wells. And on the right is anything blue. There was no particular chemical that was noted. But anything with red or a different color, there were chemicals, either natural or man-made, that were detected, but not verified as to actually what they were. So it's a very busy graph, so we should probably move on from it.
Well, just one thing I want to point out, that big red bar at the top, that's a monitoring well in a neighborhood that's fully on septic. We know there are issues there already, and it did in fact show lots and lots of substance.
Could I ask a question?
Yeah, go ahead.
So if the subwater is flowing from the south to the north, do you have your monitoring well to the north of that condensed
Yes.
population area?
Yes,
And then the other question would be, on some of you said man-made or natural?
Natural chemicals,
Yeah,
not
I mean,
chemicals,
so-
but natural substances in the water.
things like
Right,
humic
so-
acid tannins that you see that darken the
Tannins,
water,
lignins.
those show up here too.
Right, but I mean, why not just eliminate anything that's natural from your graph, because we're not gonna do anything about anything natural, like if there's a copper buildup or iron or sulfur, whatever it is.
And that's
If
exactly what
we'd
we're
make
gonna.
the graph a little more readable.
Yeah, this is just, we're explaining kind of a research philosophy here, and this is just a documentation of what they actually do. But we'll get to some, like, more of the hard findings. So, so we sampled 10 wells, and all the people voluntarily allowed us to do this special sampling. We wanted to look at some common contaminants. Sucralose is one. Sucralose is a very common contaminant. It doesn't break down in groundwater. It'll exist for eons in the
Is that
groundwater.
artificial sugar?
Yeah, it's artificial sweetener.
Splenda.
It's everywhere.
Caffeine, caffeine and BAM, which is herbicide, sulfamethoxazole is an antibiotic, and there were some other compounds that were tentatively detected. So
Isn't caffeine natural though?
No.
no,
No.
it's a
It's
man-made.
not in caffeine beans or coffee
Oh,
beans?
coffee
Well,
beans?
but it wouldn't naturally be in the groundwater system.
Oh.
It's there because of human activities.
Okay.
In other words, we drink coffee, it gets into the
Yes, yes.
water,
Yeah,
it shows up in groundwater.
okay, okay,
Yeah, it's
thank
not a
you.
man-made chemical.
Okay.
It's in the.
Yes, that's what.
And I've heard that Splenda just kills your gut.
What'd you say?
Splenda actually eats your gut.
Yeah, it's not, that's why I'm trying to get off Diet
Yeah.
Pepsi, which is my favorite.
Right.
Yeah, at
It's
high
not- it's not
concentrations,
good for
it's
Just heard
actually-
that yesterday.
It's a toxic.
It's not good for you, for sure.
Does make some-
Next.
Go ahead, yeah. These are busy. These are just basically as their machine goes through and it detects, these are molecular weights of chemicals, essentially just showing you can go right through those.
Well, so Gary, key point, this is not something you'd expect in septic. This is agricultural, herbicide, lawn care, something else.
This is a pre-emergence herbicide. So in other words, you put it down to keep weeds from growing up.
Second cousin to Roundup or something like that?
It's different, but it's really popular. If you go to Costco during the spring, you can buy big things, but it's used a lot.
So these are the kind of the final results of, and this is this is a very expensive process, as you might guess. It's about $554 per sample, and each sample is actually 3 liters, 1 liter bottle. So, but it's very informative. So caffeine was found in 2 wells. The BAM was found in 6 or 7 or 8, excuse me. Sucralose was pretty ubiquitous across them all, and then there were very small detections of the antibiotic, as you can see. So what we pointed out to people we'll be presenting is we don't know the public health meaning of what this is. We're talking about parts per trillion. And for us to actually drill down further would be a phase 2. We'd actually have to go through, find analytical laboratories that could do these analysis specifically and then have them do them and repeat what we just did, only with a different procedure to fully verify. And even then, we have to evaluate, maybe engage toxicologists at DOH to see if there's even actually a problem. To me, what it is just evidence of our human signature. If we know it's in surface waters, lot demonstrates it's in groundwater, this demonstrates the same thing. The question is, what does it really mean in terms of public health impact? So there we go.
So 47% of our samples exceeded the early warning, 15% exceeded the Department of Health trigger. We found large numbers of contaminants of emerging concern. Pesticides, industrial, commercial, pharmaceuticals, not all of these are related to human wastewater. There's definitely other sources at play. Art, do you wanna summarize the conclusions?
And so the conclusions, and we're doing this to gather information, and I think probably the big thing that it allowed us to do is update and kind of fine tune the groundwater model that Kevin has developed. That's really a good resource or a good tool for us in the future to kind of keep track of things and to be able to evaluate how different land use activities might impact water resources. So that's a big win on this particular project for that. The other thing that we found, again, that even though we've exceeded some of those trigger levels, with the exception of that monitoring well, the wells, at least when we're talking about nitrate, they met the public health standards. So there's some areas where things are rising and there's some concerns there, but we didn't find any well that required intervention. Someday we'll talk to you about that South County Smith Prairie project where there's some wells that actually exceed the drinking water standard of 10, and that's a big concern. But we didn't have that here, so that's good news. One thing is the work that Stuart's team did, and when they were out grabbing samples and talking to folks, and actually now the follow-up work with some of the different folks who are interested in this work, is being able to inform community members about the water resources. And I think it's going to be very helpful to take this information and it'll help kind of, what's the word I'm looking for? Anyways, when we're doing education and outreach about things like lawn care and other stuff like that, it'll really help kind of cement that there is a reason why you want to be careful about what you put on your lawn and how much you use, because it can get into your groundwater. You could be drinking it a few years later, so being careful about that. And then, but there is some additional work that if we want to, I think that we recommend, if we can find funding for it, is to further characterize stuff, to do some of the work that Stuart recommended about trying to better define the quantities and help identify the sources of some of the compounds that we're finding. And I think, again, it's good information that we've gotten, and having that groundwater model stuff done. And it's, again, I think also it does raise the question, though, and that's one slide where Kevin showed, which was the cross section, is that I think we need to be able to continue to do monitoring and kind of looking at some of these sources, because it may take years. One of the projects I got to work on years and years ago was really interesting, was some of the work around McAllister. And the information that it showed is that land use activities, things that are happening today, we won't see the results of that or what impact it has on water resources for decades, in some cases, years and years. And so it's really careful that it's important to be careful now. It's also important to have tools so we can evaluate things over time to see if there are public health risks going on. We're fortunate now, the groundwater in most of Thurston County is in very good shape. It's a great, obviously tremendously valuable water resource. We need to take steps that, things like this can allow us to continue to protect things and to look at land use practices and things. What's going on there. In a way, I wish we had more time. There's a great history of some of the different things that have gone on in this area. And I think a lot of them have been effective in helping protect our water resources. And maybe that's a conversation for another day.
Oh, yeah, I mean, one of the takeaways for me was that the legacy problems are what we're looking at here. The legacy problems. The newer rules really changed the septic loading and improved things. So currently, we're installing things at a lower density, and that's obviously been
since about 1990, there's some important land use stuff that took place in that area, the McAllister Springs geologically sensitive area, and it reduced the density of on-site systems, and larger, bigger, more dense developments needed to go on sewer. And that was
But at the same time, agricultural use was heavier than ever.
Yeah, and ag is, so that's that. There's lots, as you know, there's lots of complications, about the upper Deschutes and all that. It's a lot. It's a big challenge to kind of help manage these things, or to provide information. I know I'm running long, sorry. I like this stuff a lot.
Okay,
Quick question?
quick questions, and then Commissioner Menser.
Oh.
Go ahead.
Will you be using the same wells to do your follow-up testing, or at least the same immediate area? Because maybe somebody will sell a house and that person isn't gonna let
We
you on the
certainly
property.
want to do that. We want to be able to
So
use
that's gonna
those
be
and
the
maybe
plan.
expand on it if possible.
Okay, when you did your analysis and you went to the north of the populated area, did you pick the worst of the worst? And when I say the worst of the worst, we've got quite a few trailer courts, I'm just gonna put it that way, that have their on-site septic systems singly, very questionable, put in the 50s, still there. Did you specifically pick those spots versus where you've got population, but it's more modern population with modern septic systems and drain fields? Because to me, that's the thing that gives you the credibility to really point out that, hey, something's going on here, and because of. And then my other, just real quick, is under your modeling, using best available assumptions was found to underestimate actual nitrate contamination. I don't understand, why do you use it if it's not
Okay.
performing?
Good question. We needed to have part of the problem nailed. In other words, we needed to look at the septics piece of it. That way we could say how much wasn't caused by septics. That was the 60-40 split I mentioned earlier. So 60% of the problem is caused by septics, and we can track that pretty well using the modeling. That says we've got 40% of the problems caused probably by other sources.
But going to McAllister Springs, look at all the excessive nitrate that's used there. Homes were limited, septics were limited since the nineties, and the nitrate level goes up. Can you tell the difference between that amount of nitrate, once it passes through the biomass, gets down deep? Can you tell the difference between commercial and septic system nitrate?
Very difficult.
So that's part of what Phillips is trying to
The
do.
intent of the chemical emerging contaminants is to see what the signature is. And actually, this group at UW has developed, in Skagit County, they developed a signature specific to dairies. And we're hoping to use that in Smith Prairie. It'll tell us whether in other words, so it's a surrogate with the nitrate to tell us, okay, it's nitrate. Nitrate is nitrate. It's also natural. It's naturally occurring.
Sure.
But if you have these other things and that signature, say, for example, of a dairy, then you have a connection there that may lead to some policy changes.
So you can tell the difference between alder nitrate, which is natural, and urea 46,
If,
which is
well,
condensed.
It can help, that's what this
It
is
can help.
intended to do, because like as you're aware, the nitrogen NO3, it's kind of the same no matter where it comes from. So, but if you can use this other stuff to help identify the source, then that helps you correct the problem if there is one. And getting to your question, I don't think we're able to do anything on Martin Way. A lot of those mobile home parks, the wells actually were abandoned and they were converted to cities because of problems years ago.
Yeah, but some of the outlying areas in the
Yeah.
county still have
There's
some
still some.
atrocious setups. And if we were gonna do something in the future, we'd wanna identify those as the source so that maybe we could get some grant funding or something to go towards solving the
Yeah.
problem.
Commissioner, the way it worked out, we just got lucky about where we sampled. People just happened to say yes. And so it's darn
Well,
near random.
So they tried, I know they tried to disperse things as widely across the area, but at the end of the day, it's permission.
I don't wanna use it all the time, but I'd like to see a map
Yeah, we
where your
can-
test wells are in conjunction with these others. I mean, I know where the other stuff is.
Yeah, we need to follow up. We only
Yeah,
have 30
we'll
minutes
provide- we can
today, so
provide you that
we'll follow
information.
up.
I'm sorry, ma'am, I'm using.
Commissioner Menzer?
I don't have any time left, do I?
Go ahead, I'll give you till 2:10.
Okay, well, I guess something Kevin said there toward the end where he said, rules, I'm not sure what rules he's referring to, but he said something about more modern rules on modern systems are doing okay. It's legacy septics that we're fighting. So I guess what I'm wondering is if we don't have any more septics and we just live the way we're living now, are we going to continue to see like increasing levels of loading, I guess is the word you use, or have we flattened off absent some other factors that we haven't got our hands around yet? Does that make sense, my question?
Yeah, so we do have some building new hotspots. We're working with the city of Rainier, for example, on the growth of a hotspot there. But by and large, in the rural areas, the current rules are keeping loading below the threshold of concern.
But the model though is kind of what's being used to try to determine what we think the maximum level will rise to with the current development, correct? That's part of the use of the model.
That's right. And right now, we're based on a single point in time. We sample, and if everything's okay, people are free to go. There's no check on what happens in the future. But the opposite side of that is, can you restrict land development and property use based on a modeling alone? And that's tricky also. People would challenge it. So I'm torn between those two different
Yes.
approaches.
But the model does, and that's part of the Commissioner Menzer, the idea with the modeling was to try to be able to look at current land use, and then that animation shows what do we think water quality will be in 20 years from now. That's the intent of trying to use this, and then hopefully be able to use that information to say, okay, is this a concern? Does it require a policy change, meaning commissioners and Board of Health members, or is it something we can live with? We don't really know the answer yet.
Maybe a follow
But
up.
yeah, I mean, I was trying to square what I thought I saw in the animation with what Kevin said. And like, when it comes to those last 10 years, for example, are we continuing to seeing rising levels, even though we're doing a better job with septics, or is that flattened out? It sounds like it's still, at least in certain places, there's still a rising issue to be
What are you,
keep
what are you asking is to make an assessment of the trend on the last 4 decades?
Well, no, I saw the trends the last 4 decades, but when Kevin said it's the legacy that's more causing a problem, and then that wanted me to break the trends down. Is the trend
Yeah, flooding and, yeah.
trend flattened out since we've reformed those rules, whatever rules he's referring to, or is it still even status quo, a growing problem that's going to hit that 5, is going to hit that 10 over time? And we are going to have additional development. It might be on sewer, but just kind of like how fast and looking at the last decade, let's say, how fast are we going toward those trigger levels?
Well, it could be calculated, and we have the tools to do that. We are looking at probably half a dozen sites right now. So I guess that's an area for future discussion.
What about between Grand Mountain and Tenino? That's going down.
It is going down. It is going down.
So
Smith Prairie's going up, Scatter
Yeah,
Creek
but the
Valley's
Grand,
going
yeah, we
down.
can talk about that, but you're right, the Grand Mountain stuff, I think though, that's a combination of different policies and things, that water resources, it's in much better shape than
the gun is eliminated.
the different things
That's
have
what's
been, there's been
limited.
different things that have taken place that have helped protect that resource. It's really, I think that's another big story we could have.
And more modern septic.
Yes, and I know we're running way late. This
Let's
is,
coordinate another follow-up briefing.
Yeah, we
Maybe
will-
set
we
up
will do
for
that.
an hour.
Yeah, because I was wondering, Kevin, you mentioned at the beginning, cost was a big hindrance for people, and I kind of want to discuss that, right? Like, what are the options when it comes to cost, and how do we get people back on track, and compliant where they're able to, drink their water and not providing contaminants to the soil. But I thank you all so much. Thank you for the interactive chart. I'm a visual person, so I love all the maps and the charts. Thank you so much.
wonderful lines to hear.
Yeah.
that was just to show that it's really complex and busy.
You're gonna scare me.
But, thank you
No,
all.
thank you very
very
much
much for having us.
Thank you.
2:11, we were adjourned.
Thank you.